Alright, this crazy contraption that I've kludged together here, if you guys can see that very well, consists of 10 LEDs, 4 green, 4 yellow, 2 red, 10 220 ohm resistors, can you read that? Focus? A 50K pot. Now, our 10 LEDs are plugged in to digital ports 2 through 11. And our potentiometer is going to a 0. As you can see there, then we just have ground running over there to smooth everything out. And this is mostly a software thing I'm going to show you, revisiting the map function. But basically what we're going to do is, by turning this pot up and down, create a simple bar graph that goes up and down. Now I know you say, well, that's stupid. Why would I want to do that with a potentiometer? Well, put something else in place of the potentiometer, any circuit you want, any sensor you want, and now you can have that sensor actuate a bar graph. It's really simple. I'm going to show you how to do it, and let's go over to the PC. Alright guys, here's our code for the bar graph. First line, define analog pin A0. Remember, we're using the defines now because it takes up less memory when your sketch is compiled. Define LED count 10. Change this number to however many LEDs you are using. Next, we are going to create an array of pin numbers. An array is basically just a variable that has more than one value. Okay? So ours go from pin 2 to pin 11. Next, in our setup, we're going to do a for loop just to turn on all the pins for output. And then we are going to come down here in the main part of our program and do an analog read. We're going to read the value of the potentiometer. Next, we're going to use that map command. We're going to create an integer variable called LED level, and we're going to map it to the analog sensor reading, which, as you remember, can go from 0 to 1023. And we're going to map it to the number of LEDs we have, 0 to LED count, which in this case, is 10. And that is such a useful function. I mean, I can't even tell you how useful it is. No matter what the value of your analog is, you can proportionally map it to your digital outputs. And here is where we're going to create a little for loop to turn on our pins. Now this is different than what we've done before, but if you want, listen, pay attention, it's really not that hard. We're going to create a variable called this LED and set its initial value for 0. Then we're going to say, as long as this LED is less than LED count, increment it by 1. So that's just keeping track of the LEDs. Next, we're going to come down to this if statement and say, if this LED is less than LED level. And if you remember, when we did the map command, right here is where we created the LED level. The LED level can go from 0 to 10. So, if we are on pin or LED 0 and our LED level is 5, then this is going to get written high. If we're on LED 4 and it's still 5, this is going to get written high. If we're on LED 7 and this value is still 5, it's going to go to else and write them low. And that's all there is to it. Now let me show you it in operation. Alright, now that we've uploaded our code, here's what it's going to look like. Now I have a couple of LEDs that are misbehaving here, so pardon me. You can see that one does turn on. It's not very bright. then this yellow one here doesn't want to turn on. Now that is the full length of the pot. That red LED is on, by the way. These are from different batches, so they're not all behaving the same. But you can see I can't turn the pot any further. So by using that map from the analog read to the number of LEDs, we have created a custom bar graph that uses the full value of whatever we're giving our analog feed to. Pretty easy, nothing to it. Now make something cool with it. If you like this, give me a thumbs up and share it with your friends or on websites. And if you haven't subscribed yet, what are you waiting for?